Fitness rant. The biggest problem in exercise science. 90% of the research out there just might be absolutely fucking bollocks. It lacks so many controls we may as well be attempting to measure the effects of me pissing into the wind in a hurricane while the entire continent of Africa also pisses into the same hurricane. And here's the thing. I can show you with an 8-year-old's engineering set why this is the case. I'm not saying this lightly, but a shitload of the research conducted at the very highest level of our industry is deeply flawed. Like, troublingly flawed. Massive, gaping fucking hole in the certainty of it all flawed. And again, the most upsetting part is that an 8-year-old can understand why. That's not a joke, by the way. The principles we're about to go over can be found in this 8 to 16-year-old plus engineering book. I once attended a 2-day seminar with the world's foremost hypertrophy researcher, and he was asked whether he accounted for something called a pec angle when conducting research involving a bench press. His reply was, and I'm quoting, "I don't see why that would matter." So, here's an example the 8-year-old can understand to show you why. The angle something pulls at tells you how effective it is at turning it round an axis. The closer this thing is to this, there's basically no rotation here. The more I get up to 90 degrees, also known as tangential, the more effective this force is at turning around this axis. So the angle of the pec has an effect on how well it can turn my arm around the axis of my shoulder. It's that simple. Pull at 90 degrees and you have more leverage than when you pull at 45 degrees. This means that the amount of force a muscle has to produce to create rotation around a joint is contingent upon its angle of pull. So when I get 10 people to do a bench press, the sternum angle absolutely matters. Because when 10 people do a bench press, 10 people do not experience the same internal consequences. Which means 10 people didn't do a bench press. 10 people did something and they suffered different consequences as a result of that thing. If you want to know how effective a bench press is at creating hypertrophy in those tissues and you don't understand this, you are not measuring the thing you think you're measuring. Because there are more variables at play than you have accounted for in the setup of your research, which again is why I say half of this research is like pissing in the fucking wind. It doesn't answer what we think it answers. And if a PhD at the highest level of our industry doesn't understand why that matters, what the fuck are we doing? To use another example, a recent study just found that a seated leg curl led to more growth than a prone leg curl. And therefore the conclusion is that if we train the hamstrings at a longer length, it must be more effective for hypertrophy because the seated leg curl involves a longer hamstring length than the prone leg curl. That part is technically true. Here's the bit that matters though. The design of those machines. If the prone and the seated leg curl aren't engineered in such a way that they present the same level of challenge throughout their range of movement as each other, then we can't conclude what that paper thinks it's concluded. Not all seated leg curls are as challenging as each other. Not all prone leg curls are as challenging as each other. So to compare the effects of one with the other without making sure they actually do the same thing as each other is a fucking fail. If you read the paper, it names the machine. There's no discussion of these things. And I promise you, they didn't account for it. Let's use another example. Inertia. Whenever anyone talks about the tempo that we should lift at, the only thing they ever mention is time under tension. And while that might matter to some degree, it's not the most important part about the speed with which you lift. The most important part is the speed you lift at changes the weight you're lifting. The forces you're dealing with aren't static. We all know that you weigh less on the moon than you do here, but it's not like your mass has changed. No, the force of gravity has changed. But gravity isn't the only force affecting you. If you jump up, you temporarily weigh less than before you jump. And then when you land with more force than if you just stood there. And you know this because if I place a 5-kilo dumbbell on your foot, it's fine. If I drop it from the ceiling, it feels rather different. The amount of force your muscles have to come up with and generate depends upon the forces currently acting on the object you're lifting. And that includes the speed with which you previously accelerated or decelerated it. This property, known as inertia, is again in an 8-year-old's textbook. Et voila! And And the literal only time it's ever referred to in hypertrophy research is to do with flywheel training, as though flywheels are the only thing that involve inertia. They're not. Some pulley systems lower the effects of inertia because you end up traveling a greater distance than the load does in the same time. And if you travel a greater distance than the load does in the same time, you moved faster than it, which means it didn't accelerate as much, which means you're dealing with more of it. Conversely, if the weight stack travels further than you, it is now accelerating faster than you are. And so the speed you need to lift at is dependent on the type of pulley system you might be dealing with, or how far away that load is placed from the axis it rotates around. If we have something that's quite close to the axis, it's going at a certain speed. If it's this far from the axis and rotating, it is going a greater distance in the same time versus this point in space, and therefore its rotational inertia is more pronounced than this guy. None of that is ever accounted for in any of the hypertrophy research. And again, if you've forgotten why this might matter, remember, muscles produce force in order to move your skeleton through space, which means that muscles' primary job is force production. That is contingent on those things we've just discussed. If we're not accounting for them in research, what's the point in the research? How are we standing here saying we're doing science and being smug about the conclusions we're drawing? Do you really care about the truth? Or do you just care about sounding smart and whacking a PhD after your name? Fuck that. How is this not better known? How did I spend 8 years in this industry with no one teaching me this? Why is this not the fucking foundation? But surely, Paul, this can't be true. Let's bring up another PhD level researcher. Again, another guy you'd know. And again, these guys are good guys. They're nice, great guys. This is not a critique of them as people. It's a critique of what they say and the fact that it is demonstrably wrong. The question was, how far should you perform your lateral raises? And his answer was basically to the ceiling. In other words, this versus this. For the middle head of the delt, that is not correct. When you go above your head, your arm at a certain point has to externally rotate in order to create enough space in the glenoid to get your arm up there. And if you don't believe that, rotate your arm internally and try and put it above your head. I'll wait. Cool, now you've tried that and realized I'm right. Gravity is loading us in this straight down direction. It's trying to slam me down into the floor. The things that sit on top of that axis are the things that are lined up in such a way as to fight that force that is pushing straight down. And in this position, the middle part of my delt is lined up such that it is perfectly resisting gravity. When I rotate, I have now placed the anterior part, the front part of my delt, on top. It is lined up fighting that guy. In this position, the middle delt runs across the back and wants to pull my arm in that direction. If someone tries to push down and I try and shove it that way, does it stop going down? No? Good, glad you're with me. So how exactly is going all the way up here doing anything once we get past this position for your middle delt? That's not complicated. A muscle can only shorten along the length that its fibers run. So if the fibers run and want to take your arm in that direction and the force comes down, that's not going to stop shit. An 8-year-old can understand that. This is basic shit that none of us are taught, and it is the biggest fucking travesty our industry faces. It might mean that 30 years of research has been an utter waste. Are we really searching for the truth? Are we? Are we so arrogant and blind as to not recognize this? It is a fucking joke. It is an insult to integrity and the honest search for truth that this is not better known and not accounted for. We cannot go on like this. Not unless we want to do anything other than look back at decades of research and think, well, that was a fucking waste. Let's do better. Rant out.